All good. Welcome officially to the lab. So before I actually start, I just want to tell you what happens in the next week. So next week you have a 1 week break. So by next week, I means after 14 days, you will, we will be, this is the last of the series for the virtual machines. And then from next lab onwards, we will be doing everything on the packet tracer. So we have 2 more labs to go, both based upon the packet tracer. So what I want you to do is go to the netacad.com, okay? Go to netacad.com, register for a free course there, Packet Tracer. And once you've registered, you don't have to do the course if you don't want to. It's up to you. We are not doing this course anyway. You're just registering there so that you can get your registration done. Once you did register, you need to go to the resources and download the Packet Tracer. And please download the latest version there for your Windows or Mac, whichever operating system you're using. But please download 8.0.1, okay? So that's the important thing which I want to do. So make sure you have the packet tracer downloaded, you're ready for the next lab before you come in after the break, and everything is ready. Okay, so in the next lab, we are going to look at ACLs and ZPF. So you may want to go ahead and read about them as well, watch some videos and see, how they actually work. But anyway, so yeah, next week is your holiday, enjoy your break. So that's it. So let me actually jump in first slide. So in today's lab, we are actually looking at the second part of TCP IP based attacks. So last week we actually did a quite, three different attacks on based upon TCP IP. I did go into the theory, explained you a little bit about it. And in today's lab, we are looking into 4 more tasks. So the first one is based upon the reset attack, TCP reset on telnet session. The second is based upon the ICMP blind connection reset. And third one is ICMP source quench. And the last one is TCP session hijacking. So a little bit of theory about each one of them again. So you know that there are 2 of them are based upon the TCP, right? The TCP works at layer 4. We saw that last week, okay? And ICMP works at layer 3, all right? So ICMP is a protocol which works in the background when you're doing the ping. So basically it was established just to troubleshoot. So you want to see if your connection is alive between the source and the destination. So that is where you would be using ICMP. And we did see that last week as well. A little bit more about what reset is and what source quench and this is. So basically, when you look at the TCP, first thing, what as a client you do is you're actually establishing a connection with the server. So you send a request from the client to the server, and that is actually a SYN packet, right? If the server is okay with it, the server will reply back with a SYN ACK packet, all right? And this means that server is available, server wants to connect with you, and then you send an ACK packet back to the server saying that, yes, let's establish the connection. And once you go through this step, all these 3 steps, which is 3-way handshake, all right? Once you go through all these 3-way handshake, then you have a session established between the client and the server. And on top of that, you do whatever you want, send the data or, whatever you're doing. So this 3-way handshake is what is done. Now, all these packets are actually in a flag field, which you can see in the Wireshark as well. If you dig deeper into the TCP packet and look at their header, there is a flag field which have different types of flags. So one flag you have already seen is a SYN flag, okay? The second flag which you've already seen is ACK flag, acknowledgement flag, right? Then we have another flag which is the FIN flag. So this is actually set when you are finishing the session, okay? When you want to do a graceful shutdown, graceful termination of the session, you will actually send the FIN packet. For example, the client says, enough, I have, done what I wanted to do. So the client will send fin, and then the server will send acknowledgement, and then you will send acknowledgement, and that's how you actually terminate the session. It's a proper way of doing it, graceful way of doing it. Another packet, another flag is reset, this one, RST, which is also termination of the session, but this does it abruptly, okay, quickly. So this is kind of an emergency situation where you have some flaws, and you're saying that the system has been compromised, or maybe you whatever. So this is actually another way of terminating the session, but abruptly. Okay, this is what we will use here as an attack. So in reality, you have a very good use of it, right? But our friends, okay, not very friendly, the attacker guys actually use it as their opportunity, all right? And they use it to terminate the session. Imagine the client and server doing all the hard work of, going through the three-way handshake and sending something, and all of a sudden the reset packet comes in and that session is terminated, okay? It's very, very bad. Other than that, you have urgent flag as well, and then there is another one which is a push flag, okay? Some maybe discussion for some other day. But what I want to know, I want you to remember, is that there is a flag field, which there are 6 flags here, right? 1, 2, 3, 4, 5, 6. So this is like the field is like this. And when, for example, when the client is sending the SYN packet, you have the 1 here and all other are zeros, which means that SYN is 1 and rest all the flags are zeros. So that indicates it's a SYN flag. When the client responds back, it actually makes it 1 and 1, right? That is why we say it is a SYN ACK. Both fields are 1, all other fields are zeros, right? And similarly, when you are sending an acknowledgement, you get the idea. So this is 0, acknowledgement is 1, and rest of all are zeros. So that means this is an acknowledgement flag. So basically, flags actually indicates what is the type of the control, just using the mouse, so just ignore that control, okay? So it's actually telling you what type of message, what type of packet is going on. So yeah, so reset is also one flag which actually terminates the session abruptly, and we will take advantage of it and see that in action. ICMP is another way of terminating, but this time using ICMP codes. So both of them are actually terminating the active telnet session or SSH session. But you can do it from this way, or from this way as well. Right? Okay. ICMP source quench is actually based upon the, when you're sending anything to the routers. So router actually first it processes the data and then sends it out, whichever interface it has to go out to, depending upon its routing table. Now that's a genuine case. Sometimes it happens that your packets which are incoming to the router, they are coming in too quickly, and then the router has to actually send a source quench message to the source, telling the source to, hey, please hold on, okay, slow down. So because I'm actually overwhelmed by the packets, I'm actually processing them, so I want you to slow down. So the source actually slows down, all right? So that's actually a genuine case. But think of it from the, perspective of an attacker. So attacker says, okay, hey, that's an idea. Let's actually send the source quench anyway, slow down the network, bring the network down. You know what I mean? So yeah, that's the negative side of it. That's how we can exploit it. And session hijacking is the best of all. It's the most interesting one, and it's equally difficult to attack, execute as well. So in session hijacking, what happens is same scenario. You, let's suppose, have the client and the server talking to each other. You go through the good three-way handshake, all good, and you have a session established. And now, whenever you send the data, this client sends you an acknowledgement, and you always have an acknowledgement number, remember, in your network fundamentals. So let's suppose you start from data 0, right? That's your sequence number 0. You send 10 bytes. The client says, okay, I've received 10 bytes. Okay, you say, okay, next sequence number is 11. So you send 10 bytes again. And the client says, okay, I've received these 20 because, so then next sequence number for you is 21. You know what I mean? That is how actually TCP, keeps track of the conversation. So the bad guys, right, in the middle actually wants to look into your conversation happening, and they take hold of this acknowledgement number and they make use of it. What they do is they now, pretend to be the client. Excuse me for a sorry. So the attacker will note this acknowledgement number and it will respond to the client, and the server will think that, okay, this is the normal conversation we are having. So this is my next sequence number anyway. So it is coming from the same client, the server doesn't know where it is coming from. So the attacker in this sense has avoided all this hard work, just noticing the acknowledgement number, sending the acknowledgement number, and maybe adding a data with it as well. That and data is some malicious code, anything. You can actually sneak in there, sneak in the data as well. And that data can be something which is actually deleting your files or creating your files, okay? Anything. So you are hijacking the session, which is already created between the client and the server. Get the idea? Okay, so this is what we are going to do in number 4. You got the idea? Please give me a thumbs up. So make sense? Which layer are we attacking at and what is the idea behind it? So number 4 is very, very interesting. And these 3 are pretty simple, you just launch the attack and see that in action anyway. Yeah. Server will, server is having a normal conversation with the client, and server expects the next one to be 21. Okay, you are using a Wireshark, for example, in the middle, and this is why, this conversation should be all encrypted. Nobody should be able to read your headers, all this thing. If you get hold of any information, you can utilize it. You can exploit it. Utilize is probably a wrong word, but you know what I mean. So yeah, so this is one exploit which can be used and we will see that in action today. Does it make sense? Okay, so if you have, like you have done network fundamentals and you saw if there are duplicate packets, what happens to those, maybe RTD version 3, you have seen at that. I'm not going into that detail, but yeah, before the server gets any packet from the client, if you are quick enough to send this packet first, all right, the server will take it. You know what I mean? Because your data gets executed anyway. Okay, we will see how the data gets executed. Perfect. Okay, let's see that. That's very interesting. I've already done it for 2 classes, and I'm again very, very confused. It is very difficult to launch. It needs patience. Then again, doesn't everything needs patience in cybersecurity? Okay. Network and Wireshark are the only 2 tools we will use, and I have already shared the PowerPoint slides on the MS Team, so you can go ahead and download it and use it accordingly. What I will do is just to keep the video short and in a sequential order, I will actually go through the labs once, and then it's a good idea for you to actually pay attention as well. Just, scribble, write it down on the piece of paper, whatever. But if you're trying to do it with me, probably, it's not a good idea, to be honest. and then you will have enough time to do it at the end. You know, that's what I've learned, because I've done it a couple of times now, and I've done it 6 times previously in the last 3 years. So I should be pretty, you know, comfortable going through it quickly. So first thing we need is all the 3 virtual machines active, and see, I have all the 3 virtual machines active, all good. And we want to make sure that, okay, the theory, I'm just skipping the theory, but, you know, but the main idea in this theory is, what is that? It is that, you know, these packets can be used in ongoing TCP reset session, and it resets the session, you know. However, the same reset packet can be used in attack. Okay, so this is what we are going to do. Okay, and yeah, we will be sending it to both parties, you know, to the client and the server. Both will receive the reset packet, and both will both will think that it is come from the other. Server will think that client has sent it. Client will think that the server has sent it, you know, and they will reset the session, terminate the session. So first thing, as a bit of security, we are shutting down our Wi-Fi network interface card on the server. And then from the server, we will telnet the client. Okay, so let me go to the server and telnet the client. So telnetting is a very simple command. You just telnet the IP. So the client is 2.8, and it asks for the client username. Client is cybersec client. That's the username. And the client password is cybersec. That's the password. And you see, I am actually connected to the client now. All right. From the server, I have telnetted to the client. All good. Perfect. So this is another, you know, you telnet to the client, you put the password and login, and now you are in the client mode. Your prompt has changed. Perfect, right? Now on the network, we will launch the attack number 78, which says TCP reset. Okay, 78, and simple. So we go to the attacker. And we launch the network, put in the password, choose 78, reset every TCP packet, okay, and reset, run it. And now we go to the server. As soon as we press any key, see, nothing is happening because we are not doing anything. As soon as I press any key, A, B, C, D, there you go, my connection is closed. So that's a reset, okay. The same thing you can see in action on the server, on the Wireshark as well. So let's actually make it more interesting. Go to the Wireshark, open Wireshark and observe the packets as well. See how it looks like on the Wireshark. If we listen to, suppose, the TCP packets, okay. Let me do it for the SSH this time. So when you're doing SSH, you need to type in the name at the IP. Okay, so this is how you SSH. SSH is actually more secure, right? Telnet, anything you do is in plain text. Anybody in the middle using Wireshark can read whatever going on. But if you have Telnet, sorry, but if you have SSH, everything is encrypted, all right? Okay, so let's, oh, the attack is running. You see, its connection is reset. It's not letting me connect because this is running. Let me pause it, maybe, or maybe actually close it altogether and SSH again. And there you go. Now I can put the password and I am connected to the SSH. So now I'm to the client, all right, via SSH. So if you look at the packets are generated, all good. Now if I go to the attacker, launch the attack, the session is ready, and we will send the reset. Same way, nothing different. Coming back to the server, as soon as I press any key, A, there you go, session terminated, broken pipe. And if you want to look at the Wireshark, there you go. I want to just stop it and show you these two red. It is being sent to the client and the server, both. Both are receiving it. Both are receiving the reset. You see, RST, RST. Okay. So that's the proof that, yeah, reset is done and the connection is terminated. So that's your first task. Easy. And these are all the slides which are saying that, before it was connected, as soon as pressed A, it refused, it closed the connection. Even if you do the telnet after that, the attacker is running, it will not let you connect. Okay. So using the SSH, you can do an optional exercise. You don't have to put it in the labs, but you can do it. Always, do some extra stuff and see how and what if for the curious mind. So you will see the reset acknowledgement package, which I've shown you on the Wireshark. All good, like this. Reset acknowledgement, they're showing up there. So that's your first attack. Okay, in the second one, same thing happens. It resets the session as well, but this time using the ICMP destination unreachable. So, ICMP is used for the ping. We have discussed that. And ICMP is different than UDP and TCP because ICMP does not have any data in it. It is just for troubleshooting. Okay. ICMP has many different types and codes. We looked at it in the previous labs last week. For example, type 0 is for echo reply. Type 3 is for destination unreachable. This is this task. This task's code will be using. Type 4 for the next task. So ICMP type 4 is source quench. Type 5, if you remember, this was covered in the last week. Redirect message, we saw that in action on the Wireshark as well. So we can, further look in the header of the packets on the Wireshark to confirm that our attack is working. Okay. All right. So the one which we are interested at the moment is type 3, which shows destination unreachable. Now, when a device gets this destination unreachable, it will terminate the session, just like it does in the previous cases we have seen. Okay. ICMP is still the part of protocol, it has been patched. System don't respond to it anymore, but we can see that in the older version of Linux, okay? And we will see this in Wireshark. So you may not be able to see this on the real hardware. It will not reset like the previous task, but you will see that in Wireshark, it actually shows you that, the blind connection reset is done. So once again, going to the client, filtering for ICMP. So going to the client, I'm focusing on ICMP packet only, run it and apply this. All right, let's stop this attack and close this as well. Okay, now ICMP is running. Let's actually ping from here to our friend server 10.0.2.6. Okay, so everything is going fine, perfect. We are looking at request reply, request reply, request reply. That's how the normal world of pinging looks like. Now we actually start the attack, in which we are focusing on code number 82, right? And let's go to attacker, launch the network, code number 82, snap and send, and we target the server, for example, and run it. As soon as we go to the client, we see that attack started working. And we can see at different points. One is this, you have unreachable here, you have unreachable here. And I hope my students will go one step further and click on, okay, let's stop this. Click on one of these packets, expand the header, and there you go. You have a proof, third proof as well. It's type 3 destination host unreachable, right? How cool is that? Okay. Does that make sense, right? Okay, so that's good. This is good. And then we have 3 proofs. So you can put that as a screenshot and write a little bit about it, what we are looking at. So that's the ICMP reset. Okay, let's go back and shut down the attack. Actually here. And just maybe stop the pingings as well. All good. Maybe just quit this as well. Okay. All good. So that's the second attack for you. In the third one, source quench, as I said, in the genuine life, in the genuine scenario, the router will request the source to slow down because it has to process packets and the packets are coming in a bit too fast for it to process. So this is a very good attack scenario to exploit because you're actually bringing down the network. You're slowing down the network, even if it doesn't need to be. So again, to look it in action on the client, we will be focusing on the ICMP packets. So let's go to the client, running the Wireshark. We will probe the Ethernet right interface, and we will look at ICMP. Okay, and on the attacker, maybe one more thing, we will go ahead and ping in the friend server, and there you go, everything is running fine. We go to attacker, we search for the Quench attack. There you go, 85, and we put in server's IP and run it. Come back to the client, and we see that everything is happening there. So let's stop it. And one thing is, on the terminal itself, you can see the quench keyword, source quench going on. Second, the quench is there as well. You can highlight that. And the third thing, which you can expand on this, is, there you go, your type is for source quench. Okay. So this will actually slow down the network. So anything happening from the source, any messages, any packet going from the source will slow it down. So the speed will be drastically changed. Okay. Any questions so far, guys? These 3 attacks, pretty simple, I guess. All right. So let's jump into the more interesting one, the last one, TCP session hijacking. So as I said, it's actually taking over this already running session, taking advantage of the acknowledgement number and putting your data along with it to the target. And just like this, in this scenario also, this is a normal scenario. You get the acknowledgement number, you follow, you get the acknowledgement number, but here you get the acknowledgement number and the attacker uses it and sends its data along with the acknowledgement number. It will add the sequence number and it will send the data. And server will get it. And this time in the data, we will send some commands so that they get executed. How cool is that? Let's see that in action. So what are we going to do is, as I said, it's very, very sophisticated. It requires, it's not, difficult. It just needs the patience. So now you have to put the correct information in it and just be patient with that. So first thing first, let's on the client run the Wireshark and looking at the telnet packet. So it's already running. I'm shortlisting it for telnet packet. And let's go to the server and telnet to the client. Okay. Telnet, password, first the username, server-sec client, password server-sec, and there you go. I'm connected to, turning on. Okay. All right. I'm connected to the client. Okay. Now what I'm going to do is I'm just going to press A and back key. That's it. Okay. So you do the same. I'm generating a data. Okay. So that I know where where my packet is. So I'm generating, I'm typing A and backspace. That's it, all I'm doing. Okay. Let's go back to the client and see that. So which packet, this first packet, if you look at, if you open the telnet, oh, come on, this data A, and the second one is the backspace. There you go. I need to look at this packet. So I will expand this one. Please focus on the last one, okay? So the last one, which the server is sending, you have to read the values of that TCP packet. So in this one, very important things you have to note down is your source MAC address. Again, we all will have different values. So please follow your values, okay? Source MAC address, make a note of it. I have already made note of it on my paper. Source destination MAC address, I have written it on the piece of paper. Source and destination IPs will be same for us if you are clicking the right packet. Remember, not this one, not this one, not this one. Only the one which is going from the server to the client, okay? All right, next thing, source port will be different for each one of them. Every time you do it, it will be different. So I want to write it down. 51390. 51390. I've written it down. Good. 51390. Okay. Destination for all of us will be same because we are doing telnet, right? So destination is 23. No, not a big deal. Now this is very important, guys. Next sequence number and acknowledgement number is very important. Please note carefully. Now you might not be able to see such a big number, and you might be looking at the relative sequence number. If you are looking at the relative sequence number, please right click, go to the protocol preference, and if this is ticked, please make sure it is unticked. For example, if I make it tick, you see it's just 2. All right, because it actually starts from the sequence where first sequence. So we are not actually looking at the relative sequence number. We want the absolute sequence number. So I'm going to untick it, and this is the value which I'm interested in. So I'm going to write this one down, 3411418,799. Okay, so let's write it down. 3411418,799. That is my sequence number, and this is my acknowledgement number, 240695. 240695. Sorry, 4471. Okay. Next thing I need to know is push and acknowledgement flags are 1. Good. And my window size is 237. So please note your window size as well. I have written it down. Perfect. That's it. So what you need to know? You need to know your source MAC, destination MAC address, your source port, destination port, your next sequence number and acknowledgement sequence number, the flags, the window size. Okay. And now this is what we know as an attacker. We will utilize the most important part, and what we will do, we will send a data as well, and we will make it more interesting. What we will do is we will actually add 4 to it. Okay. So we will add 4 to it because why? Because 2 bytes are for A and 2 bytes are for backspace. Okay. So we will add 4 to it, and we will send this sequence number to the client. Okay. We are targeting the client. So I will actually send 475, right? 475. But anyway, I have made note of it on my piece of paper. I'm just telling you, you have to add, all right? Because this is what you receive from the client, and you are sending to the client with your data this acknowledgement number, sequence number actually. Perfect. So let's take a look at this on the form. How will we fill this information on the form? Remember, you're selecting the packet which is from the server to the client, and your data is the backslash, and all this information is very, very important. You have to make note of it exactly as it is. Okay, so this is what it is talking about. All right. And yeah, make sure your relative sequence is unticked. And these are the values which are putting. We have to tick urgent, acknowledgement, push flags. This will be changed. Remember, whatever your window is, mine is 237, so I will use 237. And the best part here is, guys, is this. We are going to send this data. Now, what is this data? You see, this is actually the data was sent in hexadecimal format. Okay, ASCII equivalent of this. mkdir means we are creating a directory, and the directory name is hello. Okay, so we're just having fun. So when this attack is successful, it will actually create a directory on the client automatically, not automatically, what is going on. We as an attacker are creating the directory on a client. You can do anything you want. Okay, so this should be written in the form of hexadecimal values. Okay, and we will put all this in the form on the attacker form. And yeah, there should be 2 hextet and a space, 2 hextet and a space, and like this. So all this value you see is here. Okay, you can use the converter. Just Google any text to hex converter and write the command. So remember, the command is mkdir hello space hello, and do not forget enter, because if you don't enter, it will not execute. Enter, okay, and then convert. You understand? Enter should be also there. So now it will, of course, it will give me the same thing which I already have. All good. So this is what we are going to do. We are creating the file. Okay. So yeah, this is another example. You can use any converter. So let's go ahead and put in the values, guys. I will put it on the side so that I can actually relate to it. I will go to my attacker. Oh, come on. Stop the previous attacks. Launch the network, and the attack number is I think it's 32 or 36. 32, 36. Yeah, 36. This will be sent for TCP IP. Okay, let's open this, and you see it's a very long form to fill. So be very, very careful, guys, filling it. So we are selecting Ethernet. My source MAC address, I will write it down. 00 0C 29 4C 7C C9. Okay. My MAC address, destination MAC address, I have written down as 00 50 56 3C B0 17. Perfect. Okay. What I want to do next is I want to leave this field. Do not tick them. Just leave them. We have next TTL value. TTL for all of us will be 64. And our source is server, destination is the client, and this is the source port TCP source port. So I wrote it down is 51390. Yours will be different. Destination for all of is telnet 23, all good. Now the most important part is this one. So my sequence number will be first one 3411 41 8799. And the second one, remember I have to add 4 to this one. This one was acknowledgement 1 240 695 4471. So I add 4 to this and make it 75. All right. Okay, we have to take urgent flag, acknowledgement flag, and push flag. All right. And my window size is 237. I note it down as well. And that's all. Most importantly, now I want to send make directory command with the enter. So I can actually read from here as well, 6D, 6P. So I will write it down, 6D space 6B space 6469 7220 6865 6C 6C 6F 0A 0A. I think there is an extra which shouldn't be there. Let me take a look. Oh yeah, there is an extra enter. Anyway, double enter doesn't make any sense. You see, I should have one enter and 0A is actually returned. So that's single A. So just delete this one. Anyway, double A is not an issue either. It actually just, it will work anyway, right? We just need to make sure we are entering it. Okay, once everything is fine, hopefully, Ethernet 0, source destination. Okay, if there is anything wrong, you will have to put it, correctly. Then run it. Okay. Let's cross the fingers, guys, and hopefully just running it and going to the client and something is happening. So this was my previous message sent from the server, right? Next server is sending is this one. So this should have my, yeah, perfect. There you go. MKDIR, hello. Wow, how cool is that? So I am sending this data. Okay. I'm creating the directory and that is my proof. Second thing is I want to actually go to the, we don't need pings, right? So we'll just stop this. I want to actually look at the ls, the directory. And yes, I have my directory created. Perfect. Wow, how cool is that? Amazing, isn't it? Okay. Now I want you to actually, go ahead and play with this once you created the hello directory. That's it. Your lab is done. But maybe the next attack you want to do is delete this file also. No, go ahead and delete the directory. Okay. And for that, you will actually write the command like this. Let me see. What is the proper command? For example, if I make here ABC directory, right? ABC is there. I want to delete it. So hopefully it is RM ABC. No, RM doesn't. So delete ABC. No, it doesn't. RMDIR ABC. There you go. Okay, so RMDIR. So you want to go ahead on this and you want to say, I want to delete this folder and press enter. Remember, enter should be there, convert, and whatever values you get, maybe again, I have used 2 enters, but anyway. So you go ahead and you use this. Okay, once you create a directory, go ahead and delete it as well. Have fun and see if it works. I hope it does. And just be patient with it, guys. You know, make sure you just follow the steps properly. Let me just go ahead and so yeah, so we went through these 4 attacks. All right. And next week again, you have a break. So enjoy the break. Your NetAcad, go to NetAcad, please register for a free packet tracer course. We are not doing this course, remember, this is just for registration so that you can download the packet tracer 8.0.1. All right. And be ready, make sure you know how to use packet tracer. Just, maybe take this course anyway, it's very simple. And do some reading on ACLs and ZPF. And that's it. I will see you next week. I'm just stopping the recording actually. So yeah, by all means, let me know if you have any questions right now.